Hello everyone and welcome back to yet another summary video. In this video today I will be talking about the wireless communication introduction. So my name is Muhamad and Savero, and let's just jump right into it. So first of all I want to talk about a brief history of wireless communication. So the wireless communication history began way back when people started to communicate in A4 distances. This was done by signaling, such as using smoke signals, and sending messages using human messenger or carrier pigeons. Since the discovery of electromagnetism, many scientists, engineers, and inventors poured their efforts to invent the next breakthrough until the discovery of radio waves by Heinrich Hertz in 1886 that sparks the idea of telecommunication through radio waves. And in the late 1890s, Nikola Tesla, a famous inventor, successfully demonstrated the transmission of signals wirelessly through radio waves. And a few years later, Guglielmo Marconi invented the first practical radio transceiver and transmitted signal across the Atlantic. The ongoing war in the 1900s fuels the research in wireless communication technology, and in fact, many of the technology we use today is based on the inventions discovered during the World War and the Cold War. In the future, wireless network will include next-generation cellular or Wi-Fi, smart building, autonomous car, smart city, wide area network, and Internet of Things. So making a leap into the future of wireless communication comes with many challenges. In the field of network and radio, there are quite a list when we talk about challenges. One of the challenges is to provide high data rate with high accuracy to meet the need to transmit a greater amount of information. Another challenge is to increase energy efficiency, because to make a better performing infrastructure may consume more power. Hence, it is very important to increase energy efficiency so that preservation of energy for other purposes can still be met. Other challenge that appears in the network or radio field is the scarce or bifurcated spectrum. The rapid growth of user is not linear to the amount of spectrum that is utilized to deliver signals. Reliability and coverage is also another challenge in the network and radio field. Unreliable and poor coverage network hinder the in development of the future wireless network communication. And another challenge that also exists is the heterogeneous network, which means that the different type of networks are required to be able to communicate seamlessly without any border. And lastly is the challenge in the network and radio field is the seamless internetwork handoff. It is important for network to be interconnected seamlessly so that the chance of connection failure is minimized. Next is the challenges in devices and SoC or system on chips. So the challenges also exist in devices and system on chip. The first and foremost is performance. The demand to transmit, receive, and process a great amount of information require a device that is also capable to perform successfully and with very few faults. The second challenge is complexity. Complexity will increase as the component gets smaller in size, and here we are talking in nanometer scale. And size, power, cost, and energy are also a challenge in devices and SoC. Fitting the most processing power in the smallest size, consuming the least power, manufactured at the least cost, and consuming the least energy are not an easy challenge for engineers. Another challenge in the device and SoC field is high frequencies and millimeter wave. So major impediments of millimeter wave propagations are higher path loss due to higher carrier frequency, reduced scattering, which in turn reduces the available diversity, and increased effect of blockage as a result of weaker non-line of sight paths. Also, multiple antennas and multi-radio integration are also a challenge in the device and SoC. Multiple antennas configuration requires additional hardware and integration compared to a single antenna system. Also, with the multiple signals, there is a greater processing demand placed on the receiver, which can lead to tighter design requirements. The last challenge is also coexistence. Our transition into a newer technology requires some time, and in that period of time there will be a portion of users that stuck with the previous technology so that they cannot be left without any support, and this is where it becomes a challenge. The newer technology should be able to communicate and interact with the previous one so that the communication can still be carried out. Software-defined radio. So software-defined radio could be the answer to the challenges we just talked about. This radio technology allows radio to be seen as software instead of just a module. The digital signal processor, or DSP, can be programmed so that it works with any generation of networks, and the software-defined radio allows generation of high-spectrum bandwidth of the signal. Another thing we need to talk about is the Shannon limit. So the Shannon limit, or Shannon capacity, of a communication channel refers to the maximum rate of error through data that can theoretically be transferred over the channel if the link is subject to random data transmission errors for a particular noise level. So Shannon limit can be expressed in the following formula, as you can see in the presentation, and where B is actually the bandwidth, and S is the transmission power, and N is the noise. So S over N is the signal to noise ratio. So the question is, have we reached the Shannon limit of the physical layer? There are arguments to support both views. The author of Connected Planet, Kay Fitcher, and NGSM Association Senior Director of Technology, D. Warren, agree that we are currently at the Shannon limit, while according to M. Gass in the book of 802.11 Wireless Network, The Definitive Guide, argues that Shannon was wrong and there's no limit in physical layer. Moving on to the current and the future of the wireless system, it is now common for a device to support 4G or LTE cellular system, as well as the 5G system. And perhaps in 10 years' time, 6G will be the most widely used cellular system in many parts of the world. And in certain nations, millimeter wave large MIMO systems as well as satellite systems such as Starlink have been used, and 5G to 7G Wi-Fi technologies as well as ad hoc and cognitive radio networks are among the wireless systems that might come in the near future. Energy harvesting systems are another developing technology in which energy is derived from a mechanical system such as a turbine system to create a power for wireless communication system rather than a battery. A power source derived from chemical or molecular system is an unusual example of an emerging system that still has space for improvement and innovation. So with that being said, that is it for the presentation. I hope you guys can learn something today, and I am truly sorry if there's a confusion in my explanation. I hope I will see you guys in the next one. See you later.